everybody, and thanks for coming. So I want you to put your hand up if this is your first inaugural lecture. Like, I mean, it's my first inaugural lecture, but this is the first time you've been to an inaugural. So you might be wondering what this is all about. Well, it's all about me. I'm a professor now, so what that means is that you sit there and I profess. The other thing you need to know about inaugural lectures is that they tend to be a celebration of the subject. They mostly focus on the positive aspects of the professor's work. This lecture, not so much. So I am going to talk to you about engineering, but I'm not going to tell you how great engineering is. That's what you're after, watch Top Gear. I could certainly use the audience numbers at the moment. And so I will talk about engineering, but I might give the impression at some points during this lecture that I don't love all of engineering ever. That might come as a bit of a shock to some of you, but too late. They've already made me a professor. So it's time you heard the truth. Now, engineering will save the world. Oh, I'm going backwards. Professor. We have the technology. So engineering will save the world, or various versions of that slogan, are used by engineers to recruit young, unsuspecting, idealistic people into our universities and profession. Now, it's not always clear what we're saving the world from, but there's no doubt that the engineers are important. Our UCL engineering is a bit cleverer than most. Our slogan is change the world. We don't say if that's changing for the better. But we can't be sued for false advertising. But the other thing, as Karis mentioned, the other thing that engineers do is we put a lot of effort in outreach to schools. So put your hand up if you have ever had, maybe when you're at school or if you're still at school, if you ever had an engineer come into your classroom. Yes, and maybe they did an activity with you. Has an engineer ever asked you to build a tower? No? Yes? And what kind of building materials did they provide you with? Paper and sellotape? Pasta and marshmallows. Spaghetti. Dry spaghetti, of course. Because wet spaghetti is for lunch. Now, we put a lot of effort into these outreach activities, and we still wonder why the best and brightest students don't always come and study engineering. And I think it might be because the smartest kids in that class are thinking dry spaghetti is just raw lunch. It's no more a building material than a jar of cold dolmio. And those are the students that go and study law. And apart from the weird craft activities, the engineer in your school probably told you how engineers change the world by building stuff. Important stuff like satellites and power stations and Google, and big stuff like aeroplanes and skyscrapers and Google. And the thing is, though, that when I was young, we didn't have any engineers come to my school. So I went to them, which sounds terribly nerdy, but in my defence, these were extraordinary circumstances. So when I was a teenager, I lived in a very windy town on the west coast of Australia called Geraldton. Put your hand up if you're from Geraldton. So as Aaron and Will know, it was very windy and we hated the wind. Until sometime in the 1980s, we were discovered by Northern European windsurfers. And so every year, the windsurfers, every summer, the windsurfers would fly in from the north, or for them it was flying south for the winter, and they would take over our pubs and our beaches. So I did what any self-respecting, pale-skinned, mathematically inclined girl would do. I went to engineering camp. And so while the windsurfers were taking over Geraldton, I travelled the 420 kilometres south to the University of Western Australia to the engineering summer school in Perth. And at engineering camp in Perth, we had a talk from Sue Murphy, the engineer. Now, Sue said that engineering was a great career because she could walk around the city pointing out all the cool stuff that she had built, including the new stand in the Subiaco football oval. Now, that's not Subiaco, a small town in Italy, it's in Perth. And it's not in Scotland, it's in Western Australia. And it's Australian rules football, not soccer. So the ball is oblong, not round. And they build the stadiums around an oval rather than a rectangle. But you get the picture. Sue built a sports stadium, or at least part of the sports stadium. And, you know, fair enough now, you're probably looking at that thinking, that's a bit of a rubbish sports stadium, isn't it? And the truth is that it has been demolished. But still, Sue built a football stand. And it wasn't her fault that it was the 1980s. Now, back then, I looked at that football stadium and I thought, wow, that's a lot of spaghetti. But then I found out that, no, Sue was a proper engineer, so she got to build stuff out of, like, concrete and steel. So now, let's fast forward to 2018, and Sue has just announced that she's stepping down as CEO of the water company that provides water to all of Western Australia, which is quite a big job. There's quite a lot of the west of Australia, and there is not much water. And so Sue has built a lot of stuff. Sue's built desalination plants, she's built water recycling plants, she's built pipelines, all of them out of concrete and steel and advanced membranes, nothing out of spaghetti. Not a jar of dolmio in sight. So Sue is a good engineer. I wanted to be like Sue. I failed. Now, obviously, I'm an academic, so I am essentially useless. I know that's what academic means out there in the real world, as you people like to call it. But I wasn't always an academic. I started my career over 20 years ago as an engineer on an aluminium smelter in Queensland. And yes, I made some stuff, but it wasn't nice stuff like football stands or spaghetti. I worked in the part of the aluminium smelter that made 1-tonne blocks of carbon that were burnt to make aluminium. And some of that aluminium might be here tonight. I'm just going to turn the lights up for a minute. Because those of you who are wearing a zipper, I want you to take a look at that zip, wherever it may be. Take a look at the tag. Come on, look at me, look at your zips, and tell me what's written on the tag of your zip. YKK. And YKK, is anyone? YKK. YKK. Yes, that's the right answer. You have zips that have been purchased on planet Earth. So YKK were one of the part owners of the smelter where I used to work. And they took their share of the aluminium and shipped it all over the world to be made into zippers to be put into all of your clothing. But I didn't actually make the aluminium. Part of the smelter that I worked in made the carbon anodes. Now the anodes are very important because the anodes were oxidised in a molten bath of salts at about 960 degrees. That's degrees Celsius, not Fahrenheit, because we were in Australia, not the 1700s. But what we did, we took carbon and we squashed it into 1-tonne blocks, and then we put it into a big oven, and then we sent it off to be turned into carbon dioxide with some aluminium produced as a byproduct. That's right, I made climate change. That wasn't all I made. Aluminium was not the only byproduct of our elaborate carbon dioxide production facility. We also made tar. Now this is the same stuff that gives you cancer if you smoke cigarettes. But unlike aluminium or nicotine, no one really wants tar. It's a surprisingly small market for low melting point corrosive carcinogens. So the people at the smelter started putting the tar in drums, and then the drum started to rust and the tar started to leak out again, and so then they put it in some more drums until that started to rust and leak out again. And so this was this very productive, what you might call even circular economy for a while there. And it was quite lucrative for the contractor that was desperate enough to cart tar every day, and it was really good business for the people who made drums, but it was not good for the smelter, and it was not good for the environment. So eventually, the managing director of the aluminium company wrote a very famous memo. This was like an actual physical memo, a piece of paper that someone had typed and photocopied and distributed to everybody in the carbon plant. And in that memo, he said that the tar stockpile was a disgrace, and we all needed to stop wishing that a tar fairy would come along and magic away the tar. So it was so something needed to be done. Now, it was 1997, and I'd just arrived at the smelter. I got my first job out of university. I'm a bright, new graduate engineer, ready to be like Sue. And I was going to be even better than Sue because I was an environmental engineer. So I was literally going to use engineering to save the planet. So I got myself a job at the biggest aluminium smelter in Australia. Which is one of the biggest in the world, and I get there and I find out that they have really big plans for me. I am the tar fairy. And I tried my hardest. So I was assigned this task to get rid of the tar, and I ran lots of experiments. I ran experiments to try and see how we could use the tar as a raw material rather than thinking of it as a waste product. We looked at burning it in power stations, we looked at burning it in cement kilns. We even looked at how we might recycle it back into producing more carbon anodes. I failed. I built tar in otherwise nice and tidy parts of the smelter. One of my experiments shut down the entire carbon anode production facility for several days, which may have actually done more to slow down climate change than if I'd become vegan for the rest of my life. But just like becoming vegan, that seemed to really annoy a lot of other people. So I couldn't find anything useful to do with the tar, so I started looking at waste disposal facilities, waste management contractors. And eventually the managing director signed off a six-figure sum for anyone, to take the tar off our hands. And, you know, which is every girl's dream, really, to be given a big cheque, told to go shopping at industrial waste facilities. So I sent out tender documents, and we had about half a dozen companies come back and said that they had a plan for taking our money and our tar. And so we're all set to go, except as a very diligent young environmental engineer, I had inserted into the tender documents that we needed to do an environmental audit of their facilities, which proved to be somewhat of a constraint in my ability to deliver on the project objective of making the tar disappear. So I went off to audit these potential contractors, and I hopped in an aeroplane because you can never burn too much carbon, and I flew to Melbourne. And in Melbourne, I met with waste contractor number one, Tony. So Tony was an independent waste management consultant, and I spent a really fun day in a hire car, probably a Toyota Camry, driving all over Melbourne, following Tony from one waste facility to the next, until it became apparent to me that Tony was making shit up. Tony did not have a waste disposal facility. He was just planning on taking our money and our tar and selling it on to someone else. And so I had visions of 20 years into the future, in the year 2018, on the outskirts of Melbourne, some new, beautiful suburban housing estate, Celestial Gardens, and children coming running over to their parents, saying, "Daddy, Daddy, the sand, it's sticky, black, and I have a tumour growing in my bladder." So we did not give the tar to Tony, and we did not give Tony any of our money. And then I went to Adelaide and had some slightly less criminal conversations with the waste management industry there before I flew back to Queensland, back to my bosses, a shameful failure of a tar ferry, and told them that I didn't think the Australian waste management industry was quite ready for our tar. And that my recommendation as an engineer was that we just leave it sitting on our site rotting, or at least we knew where it was. And to their credit, they agreed. And this remains one of my proudest engineering achievements. Doing nothing. So, built a sports stadium, I made sure a pile of toxic carcinogenic waste stayed right where it was. And a few years after my time, the managers of the smelter did manage to negotiate for the tar to be disposed of in a secure landfill, the stockpile of tar, and for any new tar that was being produced. Future generations of tar ferries have, as far as I know, have managed to find a way of recycling it back into the production. So the smelter did get to the right answer eventually, but for me, I had started out thinking that good engineers built stuff. I was wrong. My best engineering was to do nothing. Now, we always teach engineers to evaluate options, but the do nothing option is always the wrong answer. Do nothing is what academics do. Now, there I was, an aspiring engineer with this big project, and do nothing turned out to be the best answer. It was the best answer for the environment, it was best for the smelter's legal liabilities, and it was the best answer for the future generations of children playing in suburban developments on the outskirts of Melbourne. Now, if all of this sounds like I was doing what university accreditation boards like to call ethical reasoning, you'd be right. And this was not the last time that my ethical reasoning was to get me into trouble in my aluminium smelting career. So while I was working, I was also studying a Master's in Environmental Management part-time. And as part of that course, I needed to write an essay on environmental ethics. But I chose to write about the ethics of climate change. This was in 1999, before climate change was the greatest moral challenge of our time, and then wasn't again. So I'm 25 years old. I drive a blue Subaru. I do outrigger canoeing as a suitably tropical pastime, and I thought I was pretty clever. Now, I didn't want to write about the ethics of climate change to show how bad climate change is. My plan was to write an essay that showed that climate change, ethically speaking, was no big deal, so that I could then go back to my job as the tar ferry at the carbon dioxide factory, happy as ever. Turns out I wasn't as smart as I hoped. So I chose my essay topic, I got in the blue Subaru and I drove 100 kilometres to the nearest university library, and I got out the CD-ROMs, which were these ancient silver discs that you put into a computer, hoping that it would spit out some references to relevant journal articles. And I got the journals off the shelves, which were these massive hardcover books that if you dropped them would break your toe. And I photocopied half a dozen journal articles and I drove home again and I started writing my essay. I don't remember what I wrote, but I do remember getting to the end of the first draft of that essay and looking up and thinking, far out, as my entire career disappeared in a puff of ethical crisis. Because it turns out that climate change actually is a big deal, ethically speaking, and it's wrong to just keep pumping out carbon dioxide so that we can make more and more zippers. Now, aluminium is recyclable, and recycled aluminium only uses about 5% of the energy of newly produced aluminium. But I wasn't working on an aluminium recycling plant, and recycled aluminium was unlikely to be challenging our business anytime soon. Even now, recycled aluminium is only about 30% of all of the aluminium that's consumed in the world every year. So I printed out my essay and I mailed it into the university and I went back to work. And that was quite a strange experience the next day, walking through the gates of the smelter at 6:45 a.m, walking to the changing rooms to get changed into my uniform, which wasn't allowed to leave site because in case it was contaminated with carcinogenic tar. So I put on my uniform ready for another day of making carbon dioxide, knowing that carbon dioxide was fundamentally changing the systems that support all life on Earth. And that I was doing that so that the people that owned the smelter could make money, and people like me could make a material that was then shipped all over the world to be turned into zippers to hold up the trousers of people like you. But I was having a full-blown ethical crisis. So I did what all good 20-somethings having an ethical crisis do. I went back to university. I went back to university to perfect my powers of doing nothing. That is, I went back to do a PhD. And one way or another, I found myself at UCL. And since I've been here, I've been doing research on water in cities. And after those early days of working with a nasty carcinogenic material, it's been quite nice working with one that gives life. And water engineers and water companies, people like Sue, have really admirable aims. Their aim is to protect public health and the environment by providing a material that everybody needs to survive. And water engineers, like most engineers, are nice people, but water engineers, like most engineers, like to build stuff. Now, given the chance, a water engineer will solve all of your problems with a new dam, a new pipeline, a new desalination plant. We don't have enough water for a growing population under climate change, that's fine. Water engineers can make you more water. Of course, they don't actually make the water, but we can make just about any water, including seawater, drinkable now. But that comes at a cost. And this is why we have a desalination plant in London. So there's a possibility, even a probability, that in the future, London will have a really severe drought. And so we've got a desalination plant sitting, waiting, just in case. Now, Thames Water call this resilience planning. The engineers who designed and built it call it cash flow. And the sovereign wealth funds and banks who own Thames Water, they call it an asset, which they can then use in debt leveraging and other really complicated financial dealings that even I don't understand. I'm a professor. But the problem with desalination is entropy. So once the salt and the pollution are in the water, it takes a lot of energy to get it back out again. And energy costs money. So the London desalination plant just sits there not operating most of the time, in part because it's so expensive to run. It takes a lot of energy to run and energy costs money. And the other thing about the energy associated with desalination, for most of the world, the vast majority of the energy that supplies desalination plants comes from burning fossil fuels, which creates carbon dioxide, which makes climate change worse, which makes severe droughts more likely, which sounds like an excellent pyramid scheme for engineers. But the desal plant in London is powered by renewable energy. It's not powered by this wind farm, because this wind farm is in a place called Walkaway, which is just south of Geraldton. Now, the windsurfers stopped coming in the 1990s, and we had to find something else to do with the wind. So this wind farm produces electricity that goes to Perth and is used to power the desalination plants there, the desalination plants that Sue built. So desalination plants in London and Perth are two of the few in the world that are powered by renewable energy. So that's all right then. Except that, to my mind, if we're producing renewable energy, we should be using that to reduce our reliance on fossil fuels, not to justify increasing our energy consumption through technologies like desalination. Renewably powered desalination is like going to the gym for an hour so that you can eat cake. Now, if you're skinny to start with and you like eating cake but you don't want to put on weight, that's a pretty good strategy. But in terms of the carbon intensity of our economy, we're obese. So if you're only going to the gym so that you can eat cake, you're never going to lose weight. Renewable energy is going to the gym, desalination is cake. But of course, if we do have if we do need to find water for a growing population, the alternative, of course, is for everybody. The alternative to creating more water is for all of us to use less. This doesn't sound like a very good business deal for engineers, because if people use less water, what will we build? But if you think about it a bit harder, there are actually some really interesting engineering problems in helping people to live their lives using less water. Aaron is involved in this project, and he's the boy from Geraldton, actually, so he gets 2 stars tonight. So the problem with this kind of engineering is that it's small engineering. You need to know stuff about how people actually use water in their everyday lives. And this is not the kind of engineering that we typically talk to kids in school about. It's not engineering that's very easy for traditional engineering firms to get big contracts. And it's more uncertain. We do put a lot of effort into reducing demand for water, but typically we think of that as behaviour change, which is not for engineering, that's for social scientists. But as I've... only if you use too much water. As I've done more of this work in water, I've noticed that people are what we call a knowledge gap in engineering research. And the other thing I noticed working as an engineer for a long time is that we like to talk a lot about how important we are for society. We don't actually do much work with, society. So that's why we set up the Engineering Exchange at UCL, which tries to introduce engineers to society, or people, as we like to call them. So we put engineers together with local London communities and we help them to do projects together. And the Faculty of Engineering provided some funding so that I could spend my time setting up the Engineering Exchange, and also for Charlotte Barrow to be able to work with me. And the Bartlett also provides some funding, and we've had funding from the Natural Environment Research Council, from the Engineering and Physical Sciences Research Council, and the Royal Academy of Engineers. And over the 4 years that we've been running, we've run more than 20 projects. We've had hundreds of people involved in our work, and we've worked on topics like housing, air pollution, transport, green infrastructure. And one example of that is the Engineering Comes Home project. So the Engineering Comes Home project was really about how can we do engineering differently? How can we do engineering with communities rather than for them? That kind of research is not that easy to get funded. So now that I'm a professor, I can tell you all the secret to success as an engineering researcher is to take your ideas and try and make them fit with what the research councils want to fund. Now, a few years ago, the research councils were funding work in what's called the water, energy, food nexus. So this is the idea that we need water to grow food, and we also need water to cool power stations. We need energy to pump and treat water, and we need energy to transport food. So all of these things are interconnected, and they're all going to get more difficult all at once with climate change, population growth, and increasing consumption. Now, when engineers typically talk about this problem, they look to the big infrastructure systems, the things that they build, the dams, the power stations, the desalination plants. And we said to the Research Council, well, we want to look at the other end of the pipe where water, energy and food come together, which is in your kitchen when you're cooking spaghetti. So we got Engineering Council research funding to look at how people use water, energy and food in their homes and to work with them to design alternative systems for delivering those needs with reduced environmental impact. But there's a bigger point to this because most engineers just look to the big systems for their solutions, the big infrastructure systems. And when those pipes and wires come to the front door, they put their hands up and say, oh, that's behaviour, that's not engineering. And so I think what happens is that engineering, which actually is a really powerful profession, which does have the potential to change the world, misses out on a whole bunch of information and a whole lot of solutions to really complex problems like the water, energy, food nexus. And so that's why we've been trying to do this research differently. So in the Engineering Comes Home project, Charlotte Johnson knocked on a lot of doors of residents on the Meakin estate in Southwark. And she asked them how do they use water, energy and food and what were their ideas for doing these things differently. And then we ran a workshop with Kat Austin and colleagues from II Lab and Rob Comber and folks from Newcastle University. We ran a series of workshops with people talking about what are technological alternatives. And then my colleague Aidwan is here. Aidwan Boreon from Civil Engineering took a really big engineering tool, life cycle assessment, and turned it into a method that everyday people could use sitting around a table on a tablet to look at the environmental impacts of those different technologies and options that we were talking about. And, by and large, it worked. At the end of the project, with Peter Melville-Shreve from OTA Analytics, we installed a smart rainwater harvesting smart rainwater harvesting system on the Meakin estate, and we learnt a lot about how to design things from the bottom up, how to work with communities rather than for them. Now, since then, we've been using these same methods with residents in Somerstown, just on the other side of Euston Road, looking at the problem of air pollution. And Aidwan and I are looking at how communities engage with infrastructure projects. Aidwan's been looking at the Energy Garden project, which is putting renewable energy and community gardens on the London Overground. And I've been looking at how the Tideway project, the big super sewer that's being built under the Thames at the moment, how they're engaging with communities around their construction sites. And we also have been just awarded funding with Imperial College and again residents from the Kipling estate to look, and people all over London actually, on a big 5-year project funded by the Natural Environment Research Council to look at how we might better engage Londoners from the bottom up all the way through the corridors of power to better engage in coming to integrated solutions to the water challenges that we're facing. So we're working with engineers. We're working with engineers who are doing big stuff. We're working with engineers who are doing small stuff. And we're looking at how can we all work together to get better, more sustainable outcomes. So engineering, as it stands, is unlikely to save the world. Most engineering is done so that other people can make money. And there is nothing wrong with that. But I think when we're getting the kids to build the spaghetti towers, we should at least be honest with them about what engineering is really about. And if we are serious about engineering to change the world for the better, then we could start by doing engineering differently. We could re-engineer engineering. We might acknowledge that do nothing is sometimes the best option. Sometimes the best engineering solution is no engineering. We could do more projects that involve lots of small things with lots of benefits rather than one big thing that makes money, that creates work for engineers and makes money for their clients and investors. And we could try out more of these ways of working with communities rather than for or against them. Now, engineers like Sue do a great job. She was an inspiration for my career. Big engineering is sometimes the right answer. Sometimes you do just need more water. I do not even want to think about what the South Junction toilets would be like if we ran out of water. But big is not always best. And engineers do have a lot to offer the world, but our ideas of what engineering is need to open up. I think that more engineers should have ethical crises, and they should spend more time cooking and eating spaghetti rather than torturing school children with it.